Assalamu alaikum. Our today's video is about irrational numbers. In this video, we will discuss the definition, properties, history, and applications of the irrational numbers. We know that there are some numbers that can be written as the ratio of two integers, and they are called rational numbers. But at the same time, we have some numbers that cannot be written as a ratio, and these numbers are called irrational numbers. For example, 0.5 can be written as 1 over 2 or 1 ratio 2. 0.333 so on can be written as 1 over 3 or 1 ratio 3. Square root of 4 can be written as 2 or 2 over 1 or 2 ratio 1. But when it comes to square root of 2, we cannot write it as a fraction or a ratio. And moreover, square root of 2 is not an integer. This idea that the square root of 2 cannot be written in fractional form was firstly given by Hippasus of Metapontum, who was a student of Pythagoras. He discovered that there are some numbers that cannot be written in fractional form. Now the question was how to separate these irrational numbers from the rational numbers, or how to identify them. We can have a good comparison between rational and irrational numbers. When we talk about rational numbers, they can be written in the form p over q, where p and q are integers and q is not equal to 0. When it comes to irrational numbers, we cannot express them as the ratio of two integers, so they are not rational, and they have decimal expansion that do not terminate or repeat. Now the question is, how can we identify them? Square root of all prime numbers are irrational. The square root of non-squared numbers are also irrational. Some special numbers like pi, phi, etc. are also irrational. Let's have a look on the examples and counterexamples of irrational numbers. Here we can see some examples of irrational numbers along with examples of rational numbers. Rational numbers and irrational numbers are complement of each other. So with the proper words, we can say that the numbers which cannot be expressed in p over q form, where p and q are integers and q is not equal to 0, are called irrational numbers. Look at the examples given in the table. Square root of 4 is equal to 2, which is a rational number. 5, 6, 7 and 8 are non-squared numbers, so their square roots are also irrational. 9 is a squared number, so it is a rational number. Let's have some fun with some special irrational numbers. Our first irrational number is pi, which is the ratio of circumference to the diameter of a circle. We have known about pi since 4,000 years ago by the ancient Babylonians. The value of pi equals 3.1415926535 so on. There are certain super crazy fans of pi, which feels a great pride in memorizing its digits. Among them, Suresh Kumar Sharma of India has made a world record in 2015 by memorizing 70030 digits of pi. Phi is the second most important irrational number, which is also known as the golden ratio. It can be found by taking a stick and breaking it into two portions. If the ratio between these two portions is same as the ratio between the overall stick and the larger segment, then the portions are said to be in golden ratio. Phi is equal to 1.6180333987, so on. The third irrational number is Euler constant e, which is also the base of natural logarithms. It was discovered in 18th century by Swiss mathematician Leonard Euler. The value of E is equal to 2.7182818284 so on. Now it is the time for the applications of irrational numbers in our daily life. Automobile engineers use pi as their everyday tasks, including the calibrating of speedometer in the wheels of the vehicles and their alignments. In the pendulum clocks, the pendulum moves in the arc of a circle with an arm of the pendulum equal to the diameter. Thus, pi figures out into adjusting the clocks for accuracy. Pi is a useful tool in calculations related to waves. Thus, when we are discussing light, sound, and electronics, we are actually using pi. The length of the diagonal of a square would always be an irrational quantity, whatever the length of the side of that square be. Or we can say that we can never find the actual length of the diagonal of a square. Hope you like our today's video. Stay tuned and stay safe.